Hey everybody, welcome to the first day of Unit 10, 10.1. We are simplifying radicals. All right, I do hope that this is going to be an easy refresher lesson for us as we did some work simplifying radicals when we learned about quadratic formula and we did completing the square. Okay, we already have a lot of these skills under our belt. So we know that something is a perfect square if it's multiplied by itself, right? 9 is 3 times 3, okay? Same rules apply for a variable now. 5x to the 6th times 5x to the 6th. Remember your exponent rules back from Unit 6. So when we multiply, we add together our exponents. So something like x to the 12th, that is technically a perfect square variable. Okay, so even though 12 is not what we consider to be a traditional perfect square, okay, because the way that exponents work is by adding together any variable with an even exponent, okay, because that means it can be split in half, is considered a perfect square. Okay, so we know that we always take the biggest perfect square that goes into a number, okay, to split it up and to simplify our radical. So for 50, we would split this into the square root of 25 times the square root of 2. So if you have your list of perfect squares, you always start from the bottom and divide up so that you hit the bigger one first. Okay, so this comes out as 5 root 2. We did a lot of this in quadratic formula. Okay, so something like 80, okay, you want to make sure that you take the biggest square because sure, you could divide 40, or 4 rather, into this, okay, but that's not the biggest number that will go in. It's actually 16 and 5. So if you start from the bottom of your list, you're going to hit 16 before you even get to the 4. Okay, so this simplifies as 4 root 5. Again, a lot of experience with this. Okay, maybe we have numbers that are slightly bigger now. Okay, so you take your list of perfect squares, and again, you divide from the bottom up. So what will this split into? Okay, this is going to be 36 and 5. Square root of 36 is 6. We don't know 5, so we leave that inside the radical. Okay, take a minute and see if you can even pause the video if you need to. Let's see if you can determine what two numbers to split this into. Okay, were you able to come up with 16 and 6? Okay, so again, if you're not getting the right numbers here, it's most likely because you have not chosen the biggest perfect square. Okay, because again, for example, 4. You could have divided 4 into this, but you would have not fully simplified. Okay, so now we're going to start putting variables underneath the square root. Okay, so in order to take the variable out, we mentioned very briefly at the start that we need to have an even exponent because we have to be able to cut it in half. Okay, because we add exponents together when we multiply. So if something does not have an even exponent, okay, we're going to split it down to the closest even number. All right, so we're first going to split up our coefficient. So for 28, okay, we're going to use 4 and 7. Okay, and then we see that x to the third is an odd number. So we need an even exponent. So we're going to use x squared, which means there's then 1x left over. Okay, because it should total 3. 2 plus 1 is 3. We add the exponents. Okay, so we can take the square root of 4 out as a 2. Okay, the 7 will remain behind. And then this x squared, we're just going to divide the exponent by 2. And that's how we take it out of the square root. So it comes outside as simply an x. Okay, and the one that was not even, this guy, that's going to remain inside the square root, and we're going to put it together with the 7. Okay, so they keep each other company. Okay, let's try that again with the exponent because that can be tricky. Okay, so start with your coefficient. So what perfect square will we break this into? We're going to use 9 and 6. Okay, now don't get confused with your exponents because 9 and 4 are perfect squares. Remember, you're dividing by 2. So you need an even exponent. So we're going to use 8 and then that leftover x. So remember, you have to go to the smaller closest even number. You can't make it bigger. Okay, and y to the 4th is already an even number, so there's no reason to change that in any way. Okay, so we only take out the ones that have perfect squares. So it becomes 3, x to the 4th, we divide by 2, y squared, we divide by 2, and then all of those other radicals, okay, remain inside as the leftover. So the variable can be tricky and it's going to take time to get used to, okay, because you're not treating the exponent like a regular coefficient. You're not square rooting that, you're dividing it by 2 in order to take it out of the radical. Okay, if you want to pause your video and try and do this one on your own, it might not be a bad idea. So I'm going to use 4 and 6. Now I see I have x to the 1st power. I do not have enough to even break that down to try and take something out of the square root. So that's going to just remain inside there, and that's going to end up not coming out. Okay, y to the 3rd, I can make it y squared and y. And then z to the 4th is already even. So remember, the exponent does not have to be a traditional perfect square number. It has to be even because you're trying to divide it by 2 in order to take it out of the square root. Okay, so this becomes 2yz squared on the outside, and remaining we have 6xy. All right, we'll try one more here for today. So 63, we want to use the biggest perfect square. Okay, are we getting better at splitting up those coefficients? I hope so. So I'm using 9 and 7 this time. Okay, 12 is already an even number that is ready to be simplified. And b to the 5th, well, I'm going to use b to the 4th and b, because that is the closest even number that is smaller than what I started with. Okay, it's just a coincidence that 4 is a traditional perfect square and also an even number, because that's what we're looking for with the exponents. Okay, one more time. We're looking for an even exponent to divide by 2 and take out of the square root. Okay, so we know that the square root of 9 is 3, and then that 12 and 4 we divide by 2. Okay, everything else remains underneath the square root. Okay, so hopefully those coefficient portions of the problem were not too terrible for you. Like I said, those variables are definitely going to take more practice and just getting used to. You have to train your mind to now start thinking about them in a different way. Okay, not looking for a traditional perfect square, but rather just an even number. All right, so please make sure that your notes are complete. You wrote down a lot of details about those exponents, and then you included any questions that you might have for class. Okay, thank you so much for watching, guys, and I will see you soon.